Hello everyone. I wanted to kind of come to the end of this course by covering a little bit more that we didn't really focus on, but sort of where you could go from here. So in this course, we've covered a range of topics from introducing R from the very beginning, installing it, basic functionality, all the way up to using statistical methods like logistic regression and ANOVA. We looked a little bit on how to import data, specifically read.table and read.csv. But there's a lot of different data types that you can actually use in R. So this lesson is going to be a little bit different than prior ones, where I'm not going to be jumping into R and showing a ton of examples, because everything I'm going to be showing here could be a lesson in and of itself. So what I'm going to do is I'm just going to go through some of the different packages that you might use to import those different data types, knowing that there also will be other packages that do similar things, depending on what works for you and what sort of functionality you're looking for. So in the domain of statistical analysis, the process of importing data is a fundamental element that precedes empirical investigation. The instructional session is dedicated to the methodologies of data importation within the R statistical environment. R, recognized for its statistical rigor and graphical capabilities, requires data as a prerequisite for analysis. The importation process, however, is frequently confronted with the challenge of diverse data representations and sources. So to pretty much sum up what this means is that if you want to do analysis in R, which is a really strong and robust tool, you need data. But the problem is a lot of times data is going to be in different forms from different sources. So how do you get that data into R? Right? Whenever we're doing a class, it's super easy where I have some CSV that I give to my students, and then they all just use read.table or read.csv, or maybe even just do the import function on the graphical interface, something like that. But a lot of times you're going to want data from sources where you need to pull from an API, or it's coming from a SQL database, or maybe it's an XML file, or maybe it was an analysis that was done in another program like SAS or SPSS, but you want to bring it into R to be able to do something a little bit more sophisticated. So the objective of this lesson then is to briefly introduce various mechanisms through which R can assimilate data irrespective of its origin or format. We're going to explore R's capacity to manage an extensive array of data types, from rudimentary text files like we've done in class to more intricate structures such as JSON or XML. Additionally, the lesson will encompass techniques for interfacing with databases and procuring data from web resources. To begin with, we're going to start with our tried and true read.table and read.csv approaches that we've done before. So we've already talked about this in the class, but we can use read.table, and then we can put the file that we actually want to import into R. So this would be a file on your computer, for example. Or you could actually put a web address there if you have some specific place where a file is. We would use header to determine whether there is in fact a header in the data, so that way R knows whether to treat that first row as the header, which would be the names of each of your columns, or whether it actually just jumps straight into data. And then you've got your sep equals, which is what your data is separated by, right? So in my example here, I have it divided by /t, which would mean that it is a tab. But oftentimes it's going to be a tab, a space, a dash, or most importantly, a comma. This would lead you to your CSV data, comma separated value. So you could do read.table and then just tell it to separate by a comma. So within the quotes, put a comma. Or you could use the command specifically for it because it's so often used, which is read.csv. So for this kind of importing, we have first our file. This is just going to be the name of the file or connection. Like I said, you can connect online to read the data from. Now this is important because whenever I was teaching this, when we're in Windows, for example, I usually just go to the actual file, right click it, hit properties, get the file path so I don't have to type it all out. Or if it's in your working directory, you don't even have to do that. But you have to remember that R uses a different file system. So you have to change the backslashes to // things like that. Then once you have that path, you need to put the actual file name exactly as it's written. So if it was something like height_weight.csv, you need to write it that way. Capitalization does matter. Next, we have our header is a logical value indicating whether the first row contains column names, right? So you could have header equals true if you have column names, or header equals false if there are no names in the first row. Sep is the field separator character used to explain how it's going to separate your different data points. Quote, this is the set of characters used to quote fields that may contain special characters, such as field separator or new line characters. So the default, of course, this would be backslash, but you've different file systems, you may have something else. Next, we have DEC or DEC. This is the character used as the decimal point in the numeric data. So in America, generally, we will use a comma to show that it's 1,000, but oftentimes we can leave it if we're dealing with data in the computer, but we will put a decimal using a dot. So if you have like 206.52, you would put period 52. But you may instead want to have some other system. For example, some other places, they will use a comma to represent the separation to the decimal. So this is where you could change that. Skip is the number of lines to skip before reading data. By default, it's set to 0. You might wonder, why would you need this? Well, a lot of times when you go online, for example, to grab files, there's going to be some text or information at the top. This might be how the data is going to be used. This might be where the data came from. This may be something that's giving credit to those who created or collected the data. So this would just be, okay, how many lines do I want to skip? Okay, start here. So that's what the skip is for. And then string as factors is a logical value indicating whether character variables should be converted to factors. And by default, this is set to true. So if you have character strings, let's say it's names, do you want it to be factors or do you want to treat it as a string, in which case you would want string as factors to be false? And then following that, I just have a brief example of what this might look like, right? We have our data, which again, I would name it something not data, because data is something that we use within functions in R. So I'd call it something like my data. You have read.table, you got your data.text, that's where the data is coming from. Header equals true, meaning it does have that column, that first row that counts for the column names. Sep equals \t, so it's going to separate data with a tab. Quote is \, so that would say that's how you would do your character breaks. Dec equals period, so that means that our decimals will be separated by a period. Skip equals 0, so we have no lines being skipped. And string as factors equals true, meaning that if I have any character strings, it will treat them as a factor. If we specifically look at the read.csv importing tool, this is just a wrapper function on read.table. Like I mentioned, it's not its own thing. It's basically just read.table, but with some of the settings kind of set up by default for you. So it's designed to read comma-separated values, or CSV files, a common format for storing tabular data. The read.csv function sets the sep argument automatically to comma by default, making it suitable for reading CSV files without specifying the sep argument. All other arguments are exactly the same as read.table. And then, as before, I have an example of what this might look like. But again, you could do the same thing with read.table. You would just then want to include what the separation between your values is. Now, one of the main methods that we've used in class is a lot of times we'll just create data. So the most common ways you can do that is you name some object, you put your arrow operator, and then from there, you can either put, C for concatenate and make a vector, you could put a single value, or you could create a data frame like here. So we have sample data, which is going to be data.frame, and then we're going to have whatever the names of the columns are. So name equals, and it's going to be Alice, Bob, Carol, and David. So name is the first column name. It's going to have 4 data, which are Alice, Bob, Carol, and David. So A, B, C, D. The second column, the name will be age, and it's going to have 25, 30, 35, 40. The third column will have a name of height. It'll be 5.6, 5.9, 5.5, and 6.1. And then the fourth column would be weight, which has values of 130, 160, 120, and 170. You don't always have to import data. Sometimes you want to create data, which I do a lot of times in class, because it's easier than trying to go find a data source that works for what I'm trying to show, if I'm not trying to show that specific thing. So I just make up some data, even if sometimes it's nonsensical data. Like a lot of times I'll use R norm and I'll just create some data from a normal distribution just to show how a function works. If you have data that's loaded into R, whether it be something you imported, maybe you made some changes to it, maybe it's data that you created yourself, you can actually write this using something like the write.table function. So now that we'll use the write.table and write.csv functions to save a sample data to data.text and data.csv. So the way that they will work is pretty much the same way you work with importing, except for now you're saying what the file will be named. In fact, I actually did this earlier. I was creating the roster for the class on who's going to do which projects, presentations, in what order. So I imported the data from the grades, I deleted all the stuff I didn't want, so I just had names. I sampled it without replacement, so each student got selected once, put them in a certain, whatever order it gave me because it was randomized, and then I wanted to write this to a CSV where I can add the topics of the projects. So I use the write.csv function. And then I need to name what it's called, right? So I use write.csv, and then I need to specifically say which data am I going to be writing as a CSV. So in my case, it was something like 4102 roster. And then after the comma, within the quotes, this is going to be what your file is actually called. So in this example, I have data.csv. So if I did this, it would save in my current working directory as data.csv. But just like when you're importing, if you want to put a file path, you can tell it to write to a specific place. So rather than putting data.csv and it going to my working directory, I could put something like c:/temporary files/ and then data.csv. And then I have row names equals false. This would be your first column. Do you have row names or not? And in my case, because it's a roster, I just have, my column names are name and project. And then I don't have row names. So for me, this would be false. If you have row names, then this is where you would set it equal to true. The next package I want to talk about is the readxl package. So the readxl package provides functions to read data from Excel files, both XLS and .xlsx formats, into your R frames. So the two main functions you will use for this are read_excel or read_xlsx. Now you might wonder, what's the difference? Because when I pull up a CSV, it pulls up in Excel anyway if I have it on my computer. Well, as I kind of showed previously, really a CSV, you could think of like a blank notebook with just the numbers separated by commas, and then every time you're on a new line, that would be how you separate rows. An Excel file actually has a lot more information in there. It's got all the formatting and metadata. So if I go into Excel and I add highlighting, I change the column widths, the column heights, I add formulas, all of this, when I save a CSV, is gone. It goes away, none of that is kept. But if I save it as an Excel file, right, either XLS or XLSX, then it's going to save all of that metadata. So this is why you might want to just, if you have an Excel file, rather than trying to import a CSV and dealing with that sort of whatever you lose, it's better to import the Excel file. I will tell you from personal experience, this is where oftentimes you're going to want to do this. Someone's going to send you an Excel file, and at the bottom, you see all the little tabs. Right? So you have different tabs for different things. Maybe they could be groups, group 1, group 2, student cohort, school district, whatever the case may be. Well, if I try to save this as a CSV, all it's going to save is the active tab that I'm in. So I would have to save, let's say I had 4 tabs, I would have to save as 4 separate CSVs. But if I save that as an Excel document, then I can actually import that and all of that information will still be available. So if you want to install this, you do install.packages. It would be the readxl package, and then of course you load it with library. If you wanted to pull an XLS document, it would be read_excel and then whatever your file path is. Or if it's an XLSX file, then you want to do read_xlsx. Next, we have the Haven package. The Haven package allows you to import files from SPSS, SAS, and Stata into R. So the main functions are read.sav for SPSS, read.dta for Stata, or read_SAS for SAS files. So this is again where you might want to bring in a file from someone else's analysis to continue on the analysis or expand on it. So for example, I've done this specifically with SAS myself. I've had people in other departments who they learned how to use SAS. They have some SAS code. Maybe they copied it from from prior work, but they don't really completely understand it, or they want me to do some further analysis on it. So they might output the file and they'll send it to me. I can read it into R using the read_SAS function. So we have read_sav for SPSS, we have read_dta for Stata, and we have read_SAS for SAS document. Then we have the RMySQL package. So the RMySQL package provides an interface between R and MySQL databases. This will allow you to connect to MySQL database, query the data, and import it to R. So now this one is going to be a little bit more complicated because you're not pulling in a file like you would when you're doing the other imports we've looked at. What you're actually doing is you are connecting to a MySQL database, meaning the data is on the database. You are then going to query the database, ask it for specific information, and then that is what you will have in R. So you're not getting the entire database. So what you would do first, again, install.packages, you would do RMySQL. Notice that R, M, and all of SQL are capitalized in this. Capitalization does matter for this. And then you need to establish a connection with that specific database. So you would use dbconnect, and then you're going to put MySQL. And then your user is whatever your username would be within that database. You have to actually have access to the database. Password equals, within quotes, you put your password. DB name, this is where you actually specify the database name. And then host, this would be, for example, where the database is located. An example of this, I do something similar. I use a different package I'll talk about later. Whenever I'm doing the stats project that I created for my Intro to Stats class, I have a PostgreSQL database that all of the data goes into, and I pull it whenever I'm doing analysis. So what I need to do is exactly this. If I need to do anything to that database, whether pulling the data, analyzing it, or even making changes, I first have to connect to my PostgreSQL database, and then I can query the data, all that kind of stuff. So once you've connected to your database, then you need to actually do your query. This is where you'll use your, in this case, MySQL commands. Things like select, star, which will tell you to select everything, or you can specify exactly what you want to select. And then from whatever table it is, right? So this would be where you need to dive into the syntax of how to use MySQL. And I do think this is tremendously important because, as we mentioned in the very beginning of this course, the number one skill you oftentimes will need when working with data, whether it be data analyst, data scientist, or anything else, would be how to use SQL. But this is how you can use it, get the data within R. You can directly query the database instead of having to go into SQL and then somehow output the data, anything like that. Now, last thing is, because you are connected to this database, the last step you want to take is you actually want to disconnect from the database. So you can do this with db disconnect and then whatever connection you created within R. If you want to connect to other SQL databases, not just MySQL, you can use the RODBC package. So this package allows you to connect to various databases such as SQL Server, Oracle, or MS Access. And then you can query the data just like before, and you can import it into R. So same thing, you're going to have some sort of connection. In this case, you would use ODBC connect. You would then say your DSN name, which is your data source name. You've got your user ID, which you do with UID, and then you've got PWD for the password. So just like before, you connect to the database, then you can do your query using whatever SQL commands that type of database would accept. This is something you would need to know based on your type of SQL, right? For example, if you're using SQLite, it's still SQL, but it might have certain functionality the other one doesn't, or vice versa. I think, for example, SQLite doesn't have left joins or right joins. I can't remember which one it is. Then from there, once you've selected that data, you can then put the data from your query into your data, run some analysis in R, and then just like before, you want to disconnect using the ODBC close command. There's also the readr package or readr package. The readr package is part of the Tidyverse collection, and I actually do plan on making a lesson about that. But specifically, most people in R are using Tidyverse, and it will provide functions to read various text file formats such as CSVs, TSVs, and fixed width files more efficiently than R-based functions. Okay, so one thing I actually want to point out here, because CSV, yeah, it does that. You can use that instead of using read.csv. Cool. But the TSV, so this is one that I personally had to use for a project where I was doing natural language processing, where we had statements that were being made. The problem is those statements, because, human language, English, is that it has commas in it, meaning I couldn't use comma separated value data because it would see each of those commas, where you might say something like, she thought the boy was smart, fast, and whatever. Well, between that, you're going to have commas. Well, it's going to see that she thought the boy was, smart, fast, and it's going to see those as separate data points within, instead of just one with commas within it. So this is where I needed to actually use TSV files. So once you have this readr package, what you can do is you can use read_csv if it is a CSV file. You could use read_tsv if it is a TSV file, or you can use read_fwf if you have a fixed width column or fixed width file that you want to access. One of the most common file types you will find online, especially if you're doing anything with JavaScript, anything online databasing, stuff like that, would be JSON files. So JSonlite package can provide functions to work with JSON data in R. You can use the JSON function to import JSON data into R as a data frame. So you would, again, install or load JSonlite, and then you can use from JSON, where J, S, O, and N are all capitalized, and then you just put your data like you would before. You put the path of it, which of course could be a server. If you have a JSON file locally, whatever you want to do. If you have XML data, The XML package allows you to import XML data into R. You would use the XML to data frame where the T, D, and F are all capitalized. It's using camel case. You use the XML to data frame function to be used to convert XML into R data frame. So again, I have personal experience with this as well. This one was more personal, less professional, but I used to play this game called EVE Online, and I was creating a spreadsheet where I could actually look at pricing in different markets in the game from any location, and then from that do sort of market analysis, all kind of things like that. Well, I was using online spreadsheets, specifically Google Sheets, which used a lot of XML data because I was constantly pulling in from these databases that are run by people for the game. And this is something I could even import into R, right? So I could use my my XML package to then get that data into R, and I could do the analysis there. So in this case, we would use XML parse to import our data, and then XML to data frame is what will then convert it into a data frame that you can use in R. The data.table package is an extension of the data.frame package that provides improved performance and additional functionality. So you would use fread function, and it can be used to read files that are CSV, TSV, or others into a data.table object. So what you would do is you would use fread, and you would read that data, whatever it is. In this case, I have data.csv, and it would put it into table data. The next package I wanted to bring up is the feather package. It provides a binary file format for fast and efficient data storage and sharing between R and Python. You can use the read_feather function to import feather formatted data into R. Now, personally, I've never used this one, but it is a thing in case that's something that you are interested in. And while the feather package was, game-changing at the time, it's actually kind of been replaced more often than not by the arrow package. So the arrow package provides an interface to Apache Arrow, allowing you to read and write Parquet files. These are highly compressed columnar storage format that has become the industry standard for fast, large-scale data science machine learning workflows. It's highly efficient for big data and serves as a modern successor to that feather format. So what you would do is you would just install the packages, use Arrow, load up your library, and then you can use the read Parquet and then whatever file it is you want. And of course, this is fast and efficient because a lot of times what we're doing at this level in the course is we're just focusing on getting the data in. It's just mostly it's made up or it's very small data. But when you start getting into that very large data, remember we talked about this early in the course, that's where you start getting into things where scale becomes a problem, where you have to focus on speed, efficiency, storage, transfer rates, all that kind of stuff. And this is a modern package that is built to do that. So while Feather was the gold standard for a while, Arrow has since replaced it. But I wanted to keep both in there just in case. Feather does still exist. You can still use it. But nowadays, most people would use Arrow. There's also the Rio package. So the Rio package is a convenient wrapper for various data imports and export functions. It allows you to read data from multiple file formats without loading in multiple packages. So this one isn't anything particular like some of the ones we've looked at previously. It's more just a collection of different types of import and export tools. So it can read CSV files, it can read Excel files, it can read SPSS files. It has just a whole bunch of collected different tools kind of available to you. Another way to import data that might be very useful is the httr package, which provides functions for working with HTTP connections. So specifically, if you're dealing with anything online with hypertext transfer protocols, this allows you to import data from APIs, from web services, things like that. So this one is actually much more commonly used than when I first started doing R. It was a thing, but now a lot of times you're going to be calling on APIs. If you ever plan on doing work with AI systems, guess what? You're using an API. You don't just jump onto and connect to something like OpenAI system. What you would do is you would have to create an API key, and then you use R, something like the httr package, to then access that from your R environment. So the way you'll use this is for whatever response you have, you'll use the get command. So get, and then you will put the location that you want to. Now you may have to put more information depending on what kind of API it is. For example, when I've used OpenAI for some of the work I've done, I had to have a specific special key that I had to use so that not anyone could connect because it would be using my tokens. So I had to have extra information. You can read more into that if something you want to get into, but just know that it does exist and R can do all these things. So once you actually have done that get, then what you can do is you can pick your content using content, your response, and then of course you can have it as parsed or whatever functions. Again, you would look this up depending on what kind of data, what kind of API or call you're doing. And then from there's going to be more arguments, just like there always are. And anytime you start using one of these, do like we always did in class, do the question mark, learn more about it, see what arguments there are, because you might need different ones depending, right? Because this is not a single source like a read.csv, or even then, that's really not. You can pull from websites or from direct file. But depending on if you're doing an API call versus a web service, you may have some different arguments you need to use. The foreign package allows us to read data from various statistical software, file formats such as Minitab, S+, and others. The main functions are read.mtp for Minitab or read.export for SAS export format. So just like before, use one of those. If someone sends analysis in one of those different programs, you can pull it directly into R using these. This next slide is actually a newer slide I had to update because it used to be that there was the Google Sheets package, which you could use to pull up Google Sheets. It has since been replaced with Google Sheets 4. So if you try to use Google Sheets, it is no longer going to work. It's been deprecated. It no longer exists. So the Google Sheets 4 package, so don't forget the 4, provides functions to read data from Google Sheets into our data frames. You can use the read_sheet function to read data from a Google Sheet given its URL or key. So in this case, again, you would load it up. You would use read_sheets within your quotes. This is where you're going to put the path to your actual Google Sheet. And then, of course, again, there's going to be arguments if it's something like if you need permissions, something like that. Another way you could get data is you could use something like the rvest package, which allows you to do web scraping. So it's a web scraping library for R that allows you to extract data from HTML and XML documents. So we'd use the HTML_nodes or HTML_text function to extract specific data from web pages. So this one kind of falls into that gray area because you're not going out and making a call, going through any sort of permission process. And a lot of sites have started, especially with the advent of AI, which constantly scrape websites, to sort of start blocking this kind of stuff. But if not, what you can do is if you have a website, you pull up like a web page, for example, you could use something like you could read the HTML_text saying, go through this website, pull all the text from it, and you're going to get some other artifacts from it. I will warn you, you're going to have to clean it up quite a bit. But this is one way you could do that web scraping. And there's other ways you can do web scraping. Now, here's why it's a little bit of a gray area, though. Remember I just said a second ago that AI companies specifically went out and they've scraped anything and everything. Well, first of all, there's always been some question about whether that's ethical or not because who owns the data? Should you be able to just grab it? It's publicly available. You should, stuff like that. But there's also the factor of cost. If you have some small website, let's say that you make a website about the game Warhammer, and it's a personal website for you and just fans of the game. You get a certain amount of traffic, maybe 1,000 visitors every month. No big deal. You pay your cost for web hosting and everything's great. But then suddenly, and this is actually something I've read an article about, you have these services where not only do they scrape your site, they constantly ping your site. They just constantly go to it. Like you're suddenly getting millions of views, even though your actual viewers hasn't gone up. But you know what does go up? The cost, because your web host costs are going to have costs that are built into how much traffic you get in your site. Higher traffic sites pay more money. So a lot of times people and companies now are starting to put the do not crawl functions within their robot text and stuff like that, basically telling systems do not allow them to crawl and do web scraping, stuff like that. So this one is kind of iffy whether it even work at this point in most places, but it is something you could possibly still do. The readtext package is specifically designed to read text from data from various file formats, including plain text, CSV, JSON, XML, PDF, and others into our data frames. So again, this one has a lot of overlap with these other things we've talked about, but one I specifically wanted to focus on here is PDF. And this is one that I personally have used because I have like a PDF and I might want to pull in the data. Again, if I'm doing like natural language processing, let's say that I have a text page with a bunch of text from a story and I wanted to extract the keywords. Specifically, we were doing research on tier 2 vocabulary words. In that case, I need to pull the actual text from the PDF. So I could use something like read.text. The OpenXLSX package is another option for reading and writing Excel files. Again, both XLS and .xlsx formats without the need of Java dependencies. Now you might wonder, I already talked about a way to read Excel files. Why would I talk about another? Well, I specifically chose this one because I wanted to bring emphasis on the fact that there are going to be many other packages that do the same stuff that I'm showing you. And there's going to be certain advantages to each of them depending on what it is you're trying to do. What sort of data? Where's the data source? What sort of arguments do you have? So just because something has been done in R does not mean that it's not done somewhere else. And it might be done better in a way for whatever you are trying to do. This next one is one that I have a lot of experience with. This is the DBI package. So the DBI package provides a database interface for R, allowing you to connect to various databases such as SQLite, PostgreSQL, and others. Using a consistent API, you can use the DB connect, which is just like the other one we did previously, and DB get query functions to import data into R. So the reason, again, like I said, I've used this quite a bit is for my intro to stats projects, I have PostgreSQL databases set up for them. This is how I actually do it. I use the DBI package. So just like before, if I want to install it, install.packages DBI, where DBI are all capitalized, load it into my library, and then I would do my connection using DB connect. And this is where you would say what type of SQL you were using. In my case, it would be PostgreSQL. And then I would put the path of where it is. I would also include the information, like I said, like my key and stuff like that. Once you've done your connection, now you need to actually do the query. So it'd be DB get query, and this is where you would say, I'm going to use this connection, the database I'm connected to. You need to say what the function is that you're using within your SQL database. So again, select, if you did star, it's going to select everything, and then from what table, something like that. So for mine, it would be something like select, instead of like star, I would have something like, I don't remember how exactly I set up because it depends on what I'm querying, but a lot of times I'll query it by date because I have prior projects on there, but I don't want to pull those projects. I only want to pull the new ones. So I'll query based on date, stuff like that. And then once you're done, as always, you want to disconnect. And you would do this with the DB for database disconnect. And you would select your connection. In this case, we wrote it as con, and it would disconnect from your database. And then the last one I wanted to just bring to your attention is the R list package. This provides functions for working with lists in R. It's useful for importing data from JSON and XML files when the data has a hierarchical or nested structure, right? So if you're doing from JSON, it's from JSON. And then if you wanted to parse that data, you do list.parse. That would put it into your data list. This is just a small sample of the different packages available in R to import data. Because what is R without data? Right? The whole point of doing statistics is to answer some question. And the way we answer that question is using data. In any definition you look at about statistics, it all revolves around data. Well, just like that, R is a programming language made for statistical analysis. It can do other things too. I've seen people make games like Snake and stuff like that in R, but that's more exception than the rule. Its hardcore purpose is for statistical analysis. And the way you do statistical analysis is you need to get data first. And a lot of times you're going to have disparate data sources in different file formats from different locations. And R has functionality that you can get in these packages to deal with any of them, right? So what you'll need to focus on, this is why we say project-based learning is really the best way to get better at programming, because you're going to have to find that data. Then you're going to have to figure out what format and where is that data and how can you get that into R. And then once you've done that, then you can start doing all the stuff we've been covering in the class. So like I said, every one of these, I could make an entire lesson on how to use and implement these different packages. But I just wanted to introduce them to you so that you know that there is this huge R ecosystem out there and tons of functionality. And this is where using that documentation, ability to read documentation that we've looked at, can be so useful as you expand using R. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.